Open your book to page 909. This lesson is on finding the limits. And let's go to example 1 to understand what the limit is. Let's say if you have a function f of x equal to x minus 1 and x over x squared minus 1. Now what happens is if you try to evaluate x equal to 1, let's say if you want to evaluate f of 1, then you're going to get 1 minus 1 over 1 minus 1, and this will equal to undefined, right? So, but what you can do is, since you cannot evaluate the value at that point, but you can find out what happened with x get closer and closer to 1, okay? And you can see what happened to the function. So limit is to find what happened when x closer to a certain value, what way y approaches to. Okay? Again, as we go over the example, it will help you to better understand. So instead of finding the value at 1, what we do is we write the limit, so lim of x minus 1 over x squared minus 1, and x approaches to 1. So what it's saying is that you want to find out what this is approaches to as x get closer and closer to 1. So when x get closer and closer to 1, the y get closer and closer to what value? So that's what the limit is. Limit is it approaches close and it get closer and closer to what value. So that's what the limit is. And so the first method we're going to do is by making a table. Okay. So what you do is you make a table. So this is x, and this is f of x. And what you do is you want to kind of cut right down the middle. And so this is when x equal to 1, right? Which you cannot allow to have, because when you put 1 in here, it's going to give you undefined. So what you want to do, you want to get closer and closer, okay? And normally, usually four decimal places close enough. And you want to start from the middle and you go out from both sides. That way you don't make a mistake. So what you do is you want to get as closer to 1 as possible. So you're going to get 1.0001. Okay, so this is you want to get more than just. So you want to get closer and closer. So what you do, what you start out with, you start with 0.9 and 1.1, and you go 0.99 and you go 1.01. Okay, now don't put 1.11 now. Okay, you just want to have 0.01 over 0.01 below, right? So you get 0.999, you get 1.001, and you get 0.9999 fourth decimal place, right? So again, 1. So again, you want to get closer and closer to the 1 and see what happened. Okay, and the way to do that is, if you want to check, right, this should add up equal to, when you add this together, the average should be equal to 1. So you add this together should equal to 2. When you add this, should equal to 2, right? So what you do is you use your calculator and you evaluate this. So when x equal to 0.9, the y, right, this is equal to y, right? You're going to get 0.5263 something. When you go 1.1, you're going to get 0.4762. Okay. Now when you go to 0.99, you get 0.5025. And when you go 1.01, you get 0.4975. Okay. When you go 0.999, normally 4 decimal places should be very accurate enough. You get 0.50025. And 1.001, you get 0.49975. When you go 0.9999, you get 0.5000. 1.001, you're going to get 0.499975. So by looking at this, you can see from both sides, it gets closer and closer to 0.5, right? It gets really close to 0.5. So what we can say is that the limit as x gets closer to 1, when x approaches to 1, x minus 1 over x squared minus 1 equals to 0.5. Okay? So what the limit means, as x get closer to 1, the y get closer to 0.5. Okay? Again, you cannot have x equal to 1 because it make it undefined, right? So the way to do is by using the limit means when x, to find out what happened as x get closer to 1, what happened to y. And then again, from the table, you can see that when x get closer and closer to 1, y is going to get closer and closer to 0.5. So that's what the limit is. Okay. Now let's go and do the example 2. So example 2, you're looking for the limit as t approach to 0 of, you have square root of t squared plus 9 minus 3 over t squared. So again, if you notice, in this case, if you make t equal to 0, you're going to get undefined. So you're not going to be able to do that. So that's why you have to use the limit. So again, you go and make a table. So you got x, or actually in this case t. So you got t and f of t. And I'm going to cut here. So again, this is going to be, the middle is where the value you're not allowed to have. So you want to get to 0. Okay? And so what you can do is, actually this one, you get fairly good values. This one is fairly easy. Again, normally you want to get values. So normally, actually you can do 3. So you can go 0.1, 0.01, 0.001, right? And on this side, since it's 0, then you can go negative, right? Like you want to go on both sides, negative 0.001, negative 0.01, and negative 0.1. So you let t equal to 0.1 and you work it out. You're going to get 0.16662, and this one, again, if you make it equal to negative 0.1, you get 0.16662. Now, if you try 0.01, you get 0.166667. This one you get 0.16667. So when this is already so close, you can see you don't even need to bother to use that. Okay? So this is equal to 1/6. If you notice, this is equal to 1/6. Okay? Or if you just keep in decimal, that's fine, because again, see over here, they already converge already. When both are the same number already, don't waste your time to get even closer because it's going to be the same number. Okay? So you can see that the limit of square root of t squared plus 9 minus 3 over t squared. Again, you cannot evaluate, you cannot make x equal to t, make a t equal to 0. So again, if you let t get closer to 0, this is going to approach it to 0.16667. If you run it off, that's fine. Okay, and that's it.